So in example 3, we are given the y is equal to 1 over x, and they're looking for d2y dx2. So that notation just means second derivative. Now before I can get the second derivative, I need to know the first derivative. And so let's begin. I have the y, which is 1 over x, and it's bad to have the x on the denominator. We cannot differentiate using the power rule if the x is on the denominator. So we have to rewrite it on the numerator as x to the power of negative 1. So where did that negative 1 come from? It came from the fact that there was a 1 on the denominator, but then we moved the base x to the numerator and it becomes a negative exponent. So that's basically the exponent rule that we call 1 over a to the power of m is equal to a to the power of negative m. In any case, now we want the dy dx, so this is the first derivative, and again, I'm looking at this expression to find the derivative, and so bring the negative 1 down and then subtract 1 from the power. So it's already negative 1, take away 1 again. So that becomes negative 1 x to the power of negative 2, and that's my solution. That's the end. So now for the second derivative, d2y dx2, we again look at the circled answer and we differentiate it. So there's a negative 1 already there. The negative 2 is going to come down and it's going to get multiplied with the negative 1. Then we subtract 1 from the power that's already there. So the total should be 2x to the power of negative 3. And that's basically the end. Now, again, keep in mind that there are times when people write down negative 1 over x squared as the final answer, or they write down 2 over x cubed as the final answer. Those are perfectly acceptable. It just depends on what you're doing with the problem later on. Are you doing more work with it or not? Sometimes it's convenient to leave it with a negative exponent. Sometimes it's more convenient to leave it with a positive exponent, but as a fraction. I have a few examples written down on example 4 and 5. I would like you to pause the video here for a moment and attempt to do the problems yourself. At least try example number 4. I think it's going to be straightforward. It's looking for d2y dx2, meaning the second derivative. So start by writing the function down, then its first derivative, and then its second derivative. Pause the video here and attempt this problem on your own. Okay, were you able to get some answers? So let's see. I'm writing the y function, and I'm writing y prime and y double prime, y apostrophe and then 2 apostrophes. That's the old notation with apostrophes, or you can write down the dy over dx notation. That's Leibniz notation. It doesn't matter really, as long as you have the right notation. One of the two is fine. So starting with the negative 6x to the power 4, the derivative is going to be negative 24, and then x to the power of 3. Again, bring the power down, multiply with the number, then subtract 1 from the exponent. Same thing again. Bring the power 2 down towards the 3. 2 times 3 will be 6. Then subtract 1 from the exponent. And that's basically my first derivative, and I'm finished. So now I need the second derivative. So again, the 3 comes down and multiplies with the 24. I believe that's going to be negative 72. And then x to the power of 2. And then the 1 comes down, meets the 6. 1 times 6 is going to be 6. And then x to the power of 0 is really just 1. So 6 times 1 is going to be 6. So that's basically the end.